For the inspiration of this video, we've got to go way back. When I was a kid, I would beg my dad to take me and my brother to our local hobby store. And in the back, they had a giant train layout, from HO scale all the way up to G scale. I wish I could find some video footage of this. I found a couple pictures on Yelp. Even hours using the Wayback Machine, I couldn't really find much. But what was so cool is that they had buttons that you could press on the outside of the layout. So you would just press the button, and it would power an isolated section of the track and allow the train to go all the way around in a loop. And when it hits this isolated section again, it'll stop and preserve the life of the train motors. So instead of just having them running 24 hours a day, when somebody wants to see them run, they can see which locomotive or whatever, press that corresponding button and see it in action, see if they want to buy it. Now, this idea would be more for a layout at home, but it could also be used in a convention environment. Although you may not want to just brick build simple buttons like these, because they probably wouldn't stand up to the abuse of overzealous children and or adults, but I do have a couple ideas for that solution as well. And we've got two different versions here. One is a strictly electrical solution, but is still 100% Lego. And the other uses an RCX, very minimal coding, but you will need either a computer with Windows XP or a USB to serial adapter and third-party software. So it gets a little more complicated there, but it does open up a few options for you. So let's get up close with this and see what's going on. Okay, so in typical battery-powered bricks fashion, we have wildly overcomplicated things here. So maybe this doesn't illustrate it very clearly. But again, we have an isolated section of track here. So I'm using two half sections of Trix Bricks track. So that's just plastic track, and it doesn't allow the electricity to pass through. I've got two sections of 9-volt track and a second piece of plastic track to isolate that section. So you can see it has its own power wires here. And then I also have, this is where the tracks are powered all the time. And then because it is just one way all the way around and comes to here, and they aren't connected, I put a second set of wires over here, because otherwise the train will go all the way around, and the further it gets away from this power connector, it will start slowing down once it gets to, in this section here. So yes, I know how expensive these are. Luckily, I got them years ago. They were all severely damaged. These are all ones that I repaired myself. But there are several solutions to that. You can just pinch a bare wire between the tracks when you connect them, or you can solder to the tracks. I've seen some people do that. That may be a bit overkill, but yeah, it sucks. If you want to get these guys, you're either going to wildly overpay for it, or the person that has one will just throw it in the trash because the wire just disintegrates on them. So this is the button design here, and it is the old 4.5 volt touch sensor, and you've got the two leads there, and that just completes the circuit from the 9-volt regulator through the button to the power wires and then back. And this is what the buttons look like. They're touch sensors. They're for the 4.5 volt era of computer controlled educational sets. So maybe not very well known, but they actually just function as a momentary switch. I've shown this in previous videos. I tend to use these quite a lot. And this differs from the 9-volt touch sensors. These, again, are the older DACTA sensors that most people probably don't even know about. These weren't used in, say, the RCX sets once they made their way to the home market. But the problem with these is that they have an internal resistance. So if you try to use this as a button, it's not really going to work at all, because all the power is going to be absorbed by the resistor inside. So what I've also done is I'm using a 9-volt pole reverser switch. So if you wanted to, you can just flip this up. And now this section of track is always going to be connected. So let's watch it go by. It's just going to keep on going. So this could be used as if you want it to keep running, you can do that. Or you can flip the switch off. And then now it's going to be down to the button to make it go again. That sure was fast, wasn't it? And I've also used the 4.5 volt touch sensors in this quick little box here. So you may have seen in a recent video, I made an entire control panel to control Lego switch tracks. So let's say I want to return this train to its siding over there and bring out the passenger train. What I would do is flip this switch over and then press the button. And you can see the switch over there flips. And now I can send the train on its way. And I'm going to go ahead and slow it down as we get closer. And let's go ahead and flip this switch back. And watch this. Now I can turn the regulator as much as I want because the 9-volt switches isolate the sections of track. So that's now isolated. This is isolated as well until we flip the switch. And then now we have control of the passenger train. I'll flip the power off. Let's return the switch back to the normal position. And this is really to show that it does work with a dual motor setup, but it does rely on inertia to get to a good spot, because it is possible for one motor to sit directly on the half section of track. And now if I try to power, the front motor isn't really able to pull the back motor that isn't powered. That's probably made worse by the fact that each motor has 9-volt lamps attached to it. So it's kind of functioning as a generator to light the lights. But as you'll see, once we get going, as long as I have, 3 axles on the power, it's going to be just fine. And this is definitely one where you're going to want the extra power running on the other side because it's just drawing that much more power. So it would have slowed down more once it reached that section. And again, if we look, we've got 3 axles on, so we're doing okay there. So now I'm going to swap some cables around and get the RCX hooked up so we can see how that works. Okay, so I've now taken the wire from these connectors and run it over to the RCX. And I am using 2 ports. This is called ganging. So I'm ganging 2 outputs together in order to get a little more power out of it. In this case, it shouldn't need it. So supposedly these can do about 500 milliamps each, something like that. It's kind of hard to find really good info. This is the older version. So this is a 1.0 version with the barrel jack power input. So that definitely helps because, this would be eating through batteries. I actually have rechargeable batteries in there. So if I try to start it now, it's barely going to move. They're like 7.2 volts instead of what it's expecting, 9. I just use them to keep the firmware loaded on here, and then power is going to be given to it externally. So again, this is one of the old school DACTA touch sensors. You could use the touch sensor from the Mindstorm sets. It'd just be a little bit harder to quickly at least build a button apparatus. So let's see. Yes, the program is running. All it does is waits for a touch input. And once the button is pressed and released, it's going to supply power to B and C outputs at the same time, same direction, and same power level. And that is important when you're using multiple outputs together. And you can watch the lamp here. I think it's supposed to power it for 2 seconds. Maybe, I think it was 2.5 if I remember correctly. But you can see it functions exactly the same as pressing the button manually, and just gets it its power and gets it on its way. And let's see if we just barely made it. So again, it's a little bit harder with multi-motor setups. And I do realize in conventions, often people are using 6 or more motors, and the motors are probably going to be throughout. They might have them on one of the wagons in the middle and on a caboose on the end or things like that. So it's only going to work for certain things. But I think it's something that could really add to your layout. And you could go the extra mile and set up a switchboard like this, and then you can control your switch tracks remotely, maybe to select which train you want to run, things like that. Just score some cool points at the Lego convention, you know, rather than having to reach over and flip switches manually. You know, this is just the kind of thing I enjoy, just using the electronics in creative ways that probably you may have never seen before. So if you're interested, I have a couple videos on motorizing switch tracks. This version is in the second video, and there are instructions in the description to build your own. The modified My Own Train passenger wagons were in a haul video, and I include instructions with that. I even have instructions for the little simple gondola cars. I'm building up a small army of them in different colors. So if this was interesting, be sure to subscribe and like so other people can find it. If you have any questions, leave them below. Thanks for watching. We'll see. I knew I forgot something. Maybe I'll splice this into the video or put it at the end. I was going to say, if you want a button that will withstand tons of abuse, arcade buttons are the way to go. They're very cheap, and they're built to take abuse, to be pressed thousands of times in quick succession, and they're very durable and hardy. And they're available in all kinds of different designs. So you could, you know, make your own little box and put maybe multiple switches that go to multiple things. You know, you could have it power a Ferris wheel or something, and if they hold it down, it runs for 30 seconds or something like that. But there's just tons of options out there, so get creative. If you do come up with any, be sure to let me know. And a good place to share that, you can join my Discord, which is linked in the description. Okay, that's it for all this time. Thanks, guys.